Hello viewers, for this experiment we'll be exploring chemical and physical changes. We'll be starting with activity 1, so let's get started. First we must put on our protective eyeglasses. Okay, now that we have those on, let's put on our latex gloves. Really important to always wear protective safety lab equipment when conducting any experiments or handling chemicals. All right, here we have 2 test tubes in our test tube rack. We'll be using a graduated cylinder. And first thing we want to do is place 2 milliliters of hydrochloric acid, which is this here. Let's get this tip off. On that way. Okay, now you want to be very careful with this hydrochloric acid and carefully measure out 2 milliliters. Now when doing this, you want to make sure you get eye level to make sure you get exactly 2 milliliters. There we go, 2 milliliters. Now before you reuse this graduated cylinder, you want to make sure that you rinse it properly before you reuse it. Alright guys, now that we've rinsed and dried out the graduated cylinder, now we're going to measure out 2 milliliters of the sodium carbonate. Alright guys, that's 2 milliliters. Now we pour the contents into the second test tube. And when you're doing this, make sure you don't forget which test tube has which chemical in it. Now what you want to do is record the color of each test tube. So for the hydrochloric acid, it appears clear to me. And for the sodium carbonate, also appears clear to me. Okay, now what we're going to need is our thermometer, and we want to measure the temperature of each chemical. Now guys, I'm going to go ahead and label these test tubes just so we don't forget. Alright guys, now while we were making sure we labeled our test tubes correctly so we don't have any errors, let's go ahead and take out the thermometer and measure the temperature of the first test tube containing the hydrochloric acid. Now that looks to be right at 22 degrees Celsius. Alright, now remember to rinse out the thermometer for reuse. Now we'll leave that there in the second test tube, and we'll give it about a minute. Alright guys, let's go ahead and look at the temperature. Alright guys, the sodium carbonate appears to also be 22 degrees Celsius. Let's record that. Okay. Then rinse our thermometer. Now we'll set it over here. Set it off to dry. Okay. Now what we want to do is mix the contents of both chemicals into one. Here we go. Now I don't know if you guys saw that, but as soon as I poured the contents, the mixtures together, it bubbled and sizzled. Now let's give it a gentle swirl. Now let's use our thermometer again. And we want to record the temperature. we could already start to see a rise in temperature. We are at 24 degrees Celsius. So we've already had a 2-degree increase. We'll just keep monitoring the thermometer for another minute or so. See if we get any other rise in temperature or in color, change in color. It still appears clear to me. Okay. We'll leave that there and come back to it. Alright guys, now we're back again. Let's check out the temperature. Still appears to be 24 degrees Celsius. Color still looks clear to me. So let's go ahead and record our observations. Now that we've recorded our observations, let's go ahead and clean everything up and prepare for activity 2. Alright guys, now we're back with activity 2 of exploring chemical and physical changes. Our last activity, we had a 2-degree rise in temperature, and color remained the same. Now for this experiment, we'll be using 10 milliliters of water that we're going to pour into one test tube, and this is filtered TDS, 0 TDS water, which means total dissolved solids. I use this from my reverse osmosis filter that I own, so we make sure we get 0 TDS, like I said, and that's measured in parts per mass. So let's go ahead and get 10 milliliters of water. Just making sure we get 10 milliliters. There it is, 10 milliliters. And we'll go ahead and label this test tube A. Now for the second test tube, we're going to add 0.3 grams of a pre-weighed sodium polyacrylate to the second test tube. Alright guys, now that we're back, we've found our sodium polyacrylate, and we want to measure out using our scale. We want to make sure we get 0.3 grams of sodium polyacrylate. And make sure our scale is zeroed out. Okay, looks like we have just a little bit more to go. Okay, we're about halfway there. Alright guys, it looks like we are there. 0.3 grams of sodium polyacrylate. We want to set that off to the side. Now you want to be very careful when pouring this into the test tube. Let's see how we're going to do this. Alright guys, looks like the contents are all there. And we'll go ahead and label this test tube B. Now as you can see, this contains somewhat of a white powder, and of course our water being clear. So we'll go ahead and record that, record the color. So we have colors clear in test tube A, which contains the water, and white in color for test tube B. Now we want to grab our thermometer again, and we're going to record the temperature of our H2O. We'll leave that there for a minute. All right, guys. Now let's come back to the water, and it appears to be right at 21 degrees Celsius. Okay. Yep, 21. Now we're going to mix the contents of test tube A into test tube B. And let's see what happens. Immediately you can see a change in color to the water, turned into a cloudy white. There seems to be some sort of chemical reaction to the water. It almost seems like a gel-like substance. Having trouble putting the test tube in here. But yeah, it seems like some sort of gel. I don't know if you guys can see it. Temperature still looks the same. Possibly 1 degree of an increase. That's relatively small, considering we started at 21 degrees Celsius. We'll leave that alone and come back to it in a minute while we jot down our observations. Alright guys, let's come back to check out the temperature of the solution. And still appears to be the same. Don't believe we got any change in temperature. So temperature stayed the same, but an obvious physical change occurred. Alright guys, let's go ahead and now that we've jotted down our observations, let's go ahead and clean up and prepare for activity 3. Alright guys, we're back for activity 3. Go ahead and put on our handy dandy goggles. And for this experiment, we're going to need the copper sulfate. Okay. Immediately I can tell it's blue in color. You guys can probably see that. Okay. And then we'll also be using the sodium carbonate. Now for this experiment, we'll need the assistance of our graduated cylinder. Let's just make sure it's completely dry. Okay, we want to measure out 2 milliliters of our copper sulfate. All right, now that we have 2 milliliters of it, let's go ahead and pour it into our test tube. Now immediately you can tell the copper sulfate is blue in color, so let's go ahead and record that. And we'll go ahead and label this test tube A. Okay, again, we want to clean our graduated cylinder with water. And let me go ahead and pour out the contents. Be right back. Alright guys, now that we've rinsed and dried our graduated cylinder, let's go ahead and measure out also 2 milliliters of the sodium carbonate. Again, get an eye level to make sure we have 2 milliliters. There we go. Got 2 milliliters. Immediately I can tell we have a clear solution. Pour that into test tube and label this test tube B. And we jot down our observations. Now we want to use the thermometer, place it into test tube A. We'll leave it in there a minute. We want to record the initial temperature. Alright guys, it appears to be 21 degrees Celsius. Let's just double check. Yep, 21 degrees Celsius. Take the thermometer out, rinse it in the water. Make sure it's dry. Now we place it into test tube B, and we'll wait a minute. Alright guys, let's record the temperature. Surprisingly, contents of test tube B appear to be 1 degree lower than the contents of test tube A. We'll say this is probably 20 degrees Celsius. Or it could be user error, but no, this appears to be 20 degrees. I'm just going to go ahead and take the thermometer out, rinse it, dry it, and I'm going to dip it back into test tube A just to make sure there was no user error on my part. We'll go ahead and leave that in there for a minute or so. Alright guys, interestingly enough, test tube A still appears to be 21 degrees, just 1 degree warmer than the contents of test tube B. Interesting. All right, now we're going to take our test tube out, rinse and dry our thermometer again. And we're going to combine the contents of the two test tubes into one. Okay, we're going to take the contents of test tube A and pour them into test tube B. Again, I can still see a blue hue in this solution. Feels kind of strange. Let's see if there was any chemical change or physical change. I can see a little bit of a physical change. The solution is no longer a liquid one. It almost seems that's some sort of gel. Temperature is still at 20 degrees Celsius. It still appears to be blue. We'll let that sit there for a minute. In the meantime, I'm going to go ahead and rinse and dry my graduated cylinder and my test tube A. I'll be right back, guys. Alright guys, and now that we come back to our test tube, still no change in temperature. Still appears to be 20 degrees Celsius. Still blue or bluish. However, there's a noticeable change in the solution. Like I said, it almost appears to be somewhat of a gel type solution. It's a little thicker than it was before. So we'll go ahead and jot down that this was probably more of a physical change. Probably a chemical change too. Alright guys, now we're going to go ahead and clean up and prepare for activity 4. Hello viewers, we're back for activity, part A of our experiment. For this we'll be using a tea candle, some ice cubes, some water, just in case anything goes wrong. Alright, so we start off by lighting our tea candle, which I'm going to use handy dandy blowtorch that I just happen to have. Alright, and we want to light our tea candle. Alright, now that it's lit, We can go ahead and turn off our blowtorch. And I love to use this thing. As you can probably see, our flame is causing a chemical change and turning the wax from a solid state to a liquid state. So a physical change and a chemical change are occurring at the same time. Let's go ahead and record this. Alright guys, now that I recorded that, I observed a physical change in the wax turning from a solid into a liquid. I also noticed a chemical change within the stem of the candle as it burns. And also noticed a change in color. Before it was a white colored wax stem, now it's a brown, almost blackish, burnt looking wax stem. So we're going to go ahead and jot this down. Okay, and then move on to part B. Now for part B, we're going to use the ice cube in our aluminum tray. Now for the ice, the color of ice is almost clearish, a little cloudy white, depending on the quality of water you may have. Here our ice cube looks to be a little cloudy white color, almost clear. Okay. Now using your forceps, you want to take the aluminum tray and hold it over the candle. Now we're probably about 30 seconds into the experiment, and we could already start to notice that the ice is starting to melt. So it's going from a solid to a liquid almost instantly. We're just going to continue to hold this over the candle until the ice is fully melted, which shouldn't take long by what we're observing. Alright guys, the ice is almost halfway melted. Alright guys, I'm going to go ahead and set this down as our ice is almost melted, almost completely gone, and record my observations. Alright guys, now as we observed, we saw the ice go from a solid state to a liquid state. So in this experiment we observed a physical change. Although the H2O never stopped being H2O, only its physical appearance changed. It's safe to say that this experiment was only a physical change. Now we're going to go ahead and move on to activity number 5. So we'll be back in a minute. Alright guys, we're back for activity number 5. And we are going to observe whether or not a physical or chemical change will occur using 5 milliliters of water. And again, this is filtered water with 0.0 TDS. So it's really filtered water. It's probably a little bit more filtered than what you would normally drink from bottled water. Okay, so we're going to use 5 milliliters. Just a little bit more. Making sure to get all the air bubbles out. Alright guys, we have our 5 milliliters. Okay, and we're also going to use sugar, which I happen to pour in this container here. Now we want to use 1 gram of sugar. So we're going to use our scale once again and measure out 1 gram of sugar. Now I'm going to use this little container to pour the sugar in. And we want to zero out the scale. And pour in 1 gram of sugar. Alright guys, we got 1 gram of sugar. Now we're going to somehow figure out how to get all this sugar in this test tube. That wasn't as hard as I thought. Alright guys, now we're going to use our thermometer and find out the temperature of the water. So we're going to leave that in there for a bit while we record the color observations. Now for the sugar, obviously the sugar is white. And our H2O is clear. Alright, let's find out what temperature our water is at. Our water is at 21 degrees Celsius. All right, now let's mix the contents. Let's dry off our thermometer. We're going to mix the contents of the water with the sugar. All right, looks like the sugar is settled down at the bottom. Let's give it a little swirl. And see if we can't make that sugar disappear and fully dissolve into the water. And as we do this, we want to carefully monitor the temperature to see if there's any change in temperature. Now that the sugar is almost dissolved, all right guys, look. The sugar has fully dissolved into the solution of water and sugar. Our temperature has remained the same at 21 degrees Celsius, and no apparent change in color. For the water, it still appears to be clear. Now the sugar has completely dissolved, so it's almost invisible. All right, let's go ahead and record our data. Alright guys, now that we finished recording our data, let's go ahead and clean this up and prepare for activity number 6. Hey guys, we're back here doing activity number 6. For this experiment, we're going to use the sodium hydroxide and the 1% solution phenolphthalein, or this chemical that I can't seem to pronounce. Alright guys, first thing we want to do is take 2 clean test tubes, again marking one test tube A and the other one test tube B, so we don't get our chemicals mixed up, since they both appear to be clear in color. So we're going to measure out 2 milliliters of the sodium hydroxide, being careful not to spill any of it. Alright guys, that's 1 milliliter. Now we go for 2. Alright guys, that's 2 milliliters of the sodium hydroxide. Alright, now as for the color, It appears clear. We're going to put the thermometer in there to monitor the temperature as we pour out another 2 milliliters of the phenylethylamine. Well, actually, guys, we don't pour out 2 milliliters of this. We're simply just going to add 1 drop of this to our chemical in test tube A. So let's go ahead and record the data. Color seems to appear clear. Temperature 22 degrees Celsius. Okay. Now we're going to take our thermometer out, rinse it, dry it, and set it aside. Alright guys, so we're going to add 1 drop to the sodium hydroxide solution. Alright guys, as soon as that drop hit this, went into the test tube, the solution immediately turned a hot pink color. Now let's dip our thermometer and see if there was any temperature change in the solution. Alright guys, it looks like the temperature remained the same, 22 degrees Celsius. We're going to record that data. And this, since both solutions first started clear and mixing 1 drop of the phenylethylamine into the sodium hydroxide turned it pink, this is a very obvious chemical change. Alright. Now we're going to go ahead and move on to part B of activity number 6, using the second test tube marked test tube B. We're going to use 2 milliliters of the hydrochloric acid. Alright guys, we're going to use our graduated cylinder to measure out 2 milliliters. It's 22 degrees. We're going to rinse and dry our thermometer. Set it aside. Hydrochloric acid. Perfect, 2 milliliters. We're going to go ahead and pour this into test tube B. We'll set this aside. Alright guys, now we're going to go ahead and measure the temperature of the hydrochloric acid, and we're going to record the color. Obviously the color is clear, and the temperature is 22 degrees Celsius. Alright guys, let's take out the thermometer, rinse it, and dry it once more. Now we're going to add the contents of test tube B into test tube A that now seems to have turned clear in color from its once hot pink. It was still somewhat of a hue of hot pink. Alright guys, as we did this solution in test tube A immediately turned pink again. We're going to insert the thermometer, and immediately I can see a rise in temperature from 22 degrees. Now we're up to 25 degrees, 26 degrees Celsius. Now let me give this test tube a swirl. Looks like now we are up to 27 degrees Celsius. It's still pink in color. Alright guys, we're going to set that off to the side and record our observations. Alright guys, let's come back to our solution test tube B and record the final temperature. It looks like it stayed at a 27 degrees Celsius. Alright guys, we're going to go ahead and clean this up. And prepare for our next activity. Alright, now we will move on to activity number 7. For this activity you need 2 test tubes, copper sulfate, and the sodium hydroxide. First we'll start by pouring 2 milliliters of the copper sulfate into one of the test tubes.
Okay, and we'll go ahead and label this test tube A. Alright, and as you notice, the color of test tube A appears to be blue. I'm going to go ahead and dip our thermometer in there to find out what the temperature is. For the second test tube, we're going to add 2 milliliters of the sodium hydroxide solution. And we'll rinse off our syringe. And we'll put it away for future use. Alright, we notice that the solution containing sodium hydroxide is again clear in color. We'll label this test tube B. Now let's find out what the initial temperature of test tube A is. This appears to be 24 degrees Celsius. Let's rinse off our thermometer, dry it, and place it into test tube B. Okay, test tube B also appears to be 24 degrees Celsius. Now we'll take out our thermometer, rinse it, place it off to the side for drying. Now you'll take contents of test tube A and mix it with contents of test tube B, and we watch carefully for a reaction. Now you want to give it a good swirl. Place your thermometer back into the test tube. Temperature appears to be about the same, if not 1 degree of increase. Solution in test tube B, now that we've mixed both contents, appears to be somewhat of a gel-like substance. We'll set it off to the side and give it a minute and see what happens. Alright guys, let's find out what our final temperature is. Looks like we're at 26 degrees, so we got an increase of 2 degrees. And it looks like our final solution is blue in color. So we'll go ahead and record our data, clean up, and prepare for activity number 8. Alright, now we're back for activity number 8. For this activity, you're going to need your pre-prepared yellow water and blue water, and we just simply took our food coloring and added 1 drop to make blue water and 1 drop to make yellow water. We have 2 test tubes. Again, we're going to add 5 milliliters of blue water to 1 test tube and 5 milliliters of yellow water to the other test tube. Alright, now for this activity, we're not going to name our test tube since it's obvious. That one is blue and the other one is yellow. We're going to take our thermometer and find out the temperature in each test tube. So we'll place that in the test tube containing blue water and record that one is blue in color and the other one is yellow in color. Alright, the temperature in the first test tube is 22 degrees. Rinse that, dry it, and place it in the other test tube. Although I suspect this water, since it came from the same source, will also be 22 degrees Celsius. And what do you know, it's 22 degrees Celsius. Right, let's dry our thermometer. Now what you're going to do is take the contents of one test tube and mix them into the other, and we'll see what kind of reaction we get. Immediately we notice that the water went from yellow to green. Now let's see if we have any sort of temperature change. So we made green water. Now you want to record our data. We took blue and yellow water and made green water. And the temperature stayed the same. Alright guys, let's go ahead and clean up and prepare for activity number 9. Okay, we're back doing activity number 9. For this one, you'll need your hydrochloric acid, your magnesium strip, some scissors, and one test tube. The first thing we're going to do is take 5 milliliters of the hydrochloric acid solution and add it to the test tube. So we'll need our graduated cylinder. And we're going to measure out 5 milliliters of the hydrochloric solution. Now that we have our 5 milliliters, go ahead and pour the contents into the test tube. Dip your thermometer and set it off to the side so we can later record the temperature. Now you're going to take your magnesium strip and cut a small piece, probably about half a centimeter. After we record the temperature of the hydrochloric acid, which appears to be 22 degrees Celsius, you're going to take your magnesium piece and throw it into the hydrochloric acid. Now almost instantly we see some fizzing of the magnesium strip. Strong indication that there's some sort of chemical reaction going on. So we'll leave that there and give it about a minute. Now we're going to take our thermometer and place it into the test tube, see if we have some sort of temperature change. Alright, it looks like the magnesium completely dissolved into the hydrochloric acid, and the temperature appears to be at a 28 degree Celsius. Go ahead and record our data. Alright everyone, make sure you want to dispose of the hydrochloric acid properly, because this stuff can burn you. And we'll be back for activity number 10. Alright, so we're back for activity number 10. For this activity, you're going to need your copper sulfate, sodium, or what I like to call salt. Morton's iodized salt works fine. And we're going to need our scale. So first you can take your graduated cylinder and measure out 5 milliliters of the copper sulfate. Alright, now that we have our 5 milliliters of the copper sulfate, pour it into the test tube. I'll set that off to the side. Now we're going to need 2 grams of salt. So you want to turn on your scale. While we wait for it to turn on, let's go ahead and dip our thermometer into the copper sulfate to record the temperature. Alright, now what I'm using here is just a little collection cup. I'm placing it on top of the scale. And very important, you want to zero out the scale before you start pouring in your salt. And when you're doing this, you want to make sure that you pour in a little bit at a time and not go over your 2 grams. Oops. Looks like I just went over. Perfect. Now we have 2 grams. Alright, let's turn off our scale, set that off to the side, and add it to our other test tube. Alright guys, let's take our thermometer out of the copper sulfate, and as you can tell, the copper sulfate is blue in color. Looks like it's 22 degrees Celsius. So we'll record our clear observations. So it's blue in color, 22 degrees Celsius. We're going to take our salt and mix it with the contents of the copper sulfate. And let's watch what happens. Looks like the salt settled down at the bottom. As you can tell, the salt is a little bit different color than the copper sulfate. Let's go ahead and swirl a little bit. Use our test tube to mix it and let's watch what happens. Alright, so as I'm mixing the salt into the copper sulfate, I'm noticing that the thermometer is actually starting to drop, and it actually feels colder in my hand. So we have a temperature drop from 22 degrees Celsius down to 19 degrees Celsius. Let's see if it drops anymore as I keep mixing. Alright, we're going to set that off to the side because we're going to come back to that in a later activity. Let's go ahead and record our data, clean up, and prepare for activity number 11. Alright, now we're back with activity number 11. For this one, we're going to use the copper sulfate and salt solution that we made in activity number 10. And we're also going to need our aluminum cup that we're going to cut pieces off of it and put it into the copper sulfate salt solution. We're going to start by cutting off little pieces of the aluminum. And we don't need very big pieces, just 1 centimeter in width and probably half a centimeter in length. Okay, now that we have our pieces, let's just cut this one a little bit more. Okay. Alright, now that we have our aluminum pieces, I left the thermometer in from the last activity to see if the temperature rose, and it did. It's actually at 21 degrees Celsius now, and as you can tell, the solution turned green on us. Alright guys, now we're going to go ahead and take our test tube and pour in some of the aluminum pieces. Alright, now I'm noticing the aluminum pieces are starting to bubble. And as I shake it, I get more of a reaction from the aluminum pieces. Now let's take our thermometer and record if there's a change in temperature. And immediately I'm seeing the temperature rise from what it was previously, 21 degrees Celsius to 30 degrees Celsius. Now we are up at 35 degrees Celsius. So there's definitely some heat being given off here. Now we're at 37 degrees Celsius, so this is actually getting pretty hot. Alright guys, we're going to leave that off to the side and record our data. Now, I can't really tell what the color of this solution is. It's almost as if it's a dirty greenish color with some sort of red specks towards the bottom, almost red, as in a rusty red color. And now, guys, we're at 42 degrees Celsius. It looks like the temperature is constantly rising. Alright guys, and as I keep swirling the test tube, it looks like the temperature is steady climbing. Now we're at 46 degrees Celsius, so this thing is actually getting pretty hot. Giving off a lot of heat. Alright guys, let's go ahead and clean up and prepare for activity number 12. Just to wrap this one up, looks like the temperature is probably still going to climb a bit, but we obviously saw a chemical and physical reaction in this activity. So let's move on to activity number 12, which will wrap up this experiment. Alright, hello everyone, we're back with activity number 12. For this activity, we're also going to use 5 milliliters of the copper sulfate solution from activity number 10. Obviously, this is a different batch, not the one we used in activity number 11. So now that we have our 5 milliliters of the copper sulfate and salt solution, I went ahead and recorded the temperature, which again is 21 degrees Celsius. And what we're going to use for this activity is the nail. And this is just a standard iron nail and a piece of sanding paper, or in this case, a sanding pad. We went ahead and already recorded the temperature and the color of the copper sulfate and salt solution. So we're just going to go ahead and start sanding away at the tip of the nail, which is the head. Okay. Now we don't need a lot of sanding, just a light sand to give it a little shine. And you can tell that the tip of the nail is actually a little bit shinier than the rest of it. So we'll go ahead and record that the nail is some shiny grayish color. Now we're going to take our copper and sulfate solution. Let's remove the thermometer out, rinse it, and set it off to dry. Now using our forceps, we're going to dip the iron nail, of course, at first, into the copper sulfate solution. And we're going to let it remain there for about a minute. I don't see any changes going on or any reactions. Alright guys, now after about a minute or so, now I'm starting to see a reaction. It looks like the iron nail actually turned into a rusty color, reddish. I'm going to place the thermometer back into the solution, see if it changed the temperature at all while I examine this nail. With the swipe of the cloth, it looks like the reddish, rusty color is actually starting to come off. But the part of the nail that was actually dipped into the solution appears to be a darker grayish color than the rest of it. Right, so here's the now. Now that I've wiped off the rust off. Okay. Now that would conclude our experiments of examining chemical and physical reactions. We're just going to go back to the drawing board and review our data. Okay. Now we're going to go ahead and clean off all of our tools and clean and sanitize our workspace. Very important that any of the chemicals that you use, you properly dispose of them. So thank you for joining us. Look forward to doing our next experiment. Trusty assistant, can you turn off the camera? Turn off the camera.
And that was the button?
Yeah, just click on it. And it's not that screen.
Your mouth's sticky.
Oh.